The Unelco
receiver I told you guys about. I was able to get a good example of the receiver, complete with plug-in coils, and we're going to go through this receiver. These two items represent some cool toys from my childhood. Sears, my parents gifted that to me probably on one of my birthdays, and I think I got the base station a little later, maybe around 1970. Both of these items are operational. And remember, it takes the plug-in coils that you put in for the antenna and for the oscillator. So I think you're going to get a kick out of this. We'll hook it up to an antenna, see if we can pick up some stations in the 21st century.
Coffee, a popular bar near the presidential palace, was full of young people watching the Euro 2024 final between Spain and England. No group has...
The Unelco Electronics Company of Baltimore, Maryland. So this was American planning for toys for the late 60s and actual production occurring in Japan. The same can be said for most electronic toys of that era. Most of them were built in Japan, even by that time. And of course the single-sided circuit board, simple bipolar type circuits, reign supreme. And both of these are 100% bipolar type designs. Let's get into the Unelco receiver. Let's see what the schematic looks like. Let's look at the part count, the construction style, and finally, let's put it on the air and see if it has any performance.
Like many of the pocket radio and portable designs of the 1960s you might be familiar with, and it uses PNP germanium transistors. This was typical. But not so fast. You see, unlike an AM radio, this receiver has to operate all the way up to 30 megahertz. The Japanese designers had to employ two high-gain, high-frequency transistors in the front end, and they decided to use Toshiba's hot new NPN transistor, the 2SC373. These things had an FT of 200 megahertz and an HFE of 200. So now we have a radio with a positive ground that uses both PNP and NPN transistors. How do you do that on a single non-bipolar power supply? Take a look at these schematics. As you can see, NPN and PNPs are typically run with the PNP with the positive ground and the NPN as a negative ground. But simply reconfiguring the bias a bit and flipping the transistor upside down, either type can be used either way. This is pretty clever. So they just flipped the NPNs on their head and ran them with a positive ground, biased them properly, and they got a mixer and an oscillator stage out of the NPN devices.
So here I've got a chassis of receiver that somebody took apart. Why would somebody take one of these receivers apart and just keep this part? But I picked this up at a Hamfest. I'll take this foundation and maybe make a little one or use it to repair another one. But having this in front of us allows us to look at the simplicity of the receiver.
Okay, here's a little introduction to the Unelco 1914 overseas shortwave receiver. We're looking down at the printed circuit board. This is a single-sided printed circuit board, composite type, very common in the 1960s for Japanese manufacture. You can see the two coil sockets. The antenna mixer plug-in coil is a simple tuned circuit coupled transformer type plug-in coil, and the RF oscillator plug-in coil is an Armstrong type. These both work with high frequency transistors. The first transistor is the RF mixer transistor, and this is a high frequency silicon NPN transistor. The oscillator located over here is also a high frequency NPN silicon transistor. Interestingly enough, the IF amplifiers, these two transistors here, are both the common 2SA53IF germanium transistors, and they're PNPs. And the output stages are also common germanium PNPs, similar to 2SB54s. Here's the driver, and here's the final stages. So this is an unusual receiver in that it uses silicon NPN along with germanium PNP transistors. Although it looks a lot like a common AM table radio or pocket radio of the time, this is a specialized receiver, and they had to use the higher frequency, higher performance RF transistors, probably from some of their FM lines. These were pretty hot Toshiba devices. Now, why do we have to use the special transistors here in the oscillator and here in the mixer? The designers had to use those transistors because we're talking about a receiver that has to operate all the way to 30 megahertz. And an ordinary germanium transistor probably would have trouble reaching that high in frequency. And they had these on hand, so they used the new silicon transistors. Now let's look at some of the other features here. Notice all of the plates on the 2-gang variable capacitor, which is the main tuning capacitor. It's approximately 505 picofarads per section. This is much higher than you'd have in an AM band only receiver, but they needed that to give the full coverage on all of those bands. Also, if you look at the IF amplifiers, we have 1, 2, 3 cans. Fairly standard for any AM receiver of the time. There's plenty of gain in this receiver. Even though we only are talking about 7 devices, we have plenty of gain with those 7 bipolar devices. Let's take a look at the schematic. Everybody is looking for a Unelco 1914 schematic. I've never found one. I've never seen one. However, I found a schematic that's kind of representative that I doctored up a little bit that we can use to talk about the circuit. Now, the first thing that's different on this schematic is the Unelco uses separate RF mixer and oscillator transistors rather than combining them into one as most AM radios do. So this would really be 2 transistors, one transistor as the front end mixer and a second transistor as the Armstrong style oscillator. I've also attempted to draw dotted lines around the coils themselves. These coils are fairly complex. There's not just a winding inside. There are pattern capacitors, bias resistors, the core itself with adjustability, and sometimes even some bypass capacity. So these are optimized plug-in coils, one for the oscillator and one for the antenna or the mixer input. Then we have fairly conventional IF transformers and IF amplifiers. This is the detector stage. In this schematic they're showing a shorted base to collector diode made of this transistor. The Unelco actually uses a real germanium diode detector in that we're taking the audio and it goes to the potentiometer and then out to the first audio driver. The AGC, on the other hand, comes down this way. It becomes filtered, and this is your AGC capacitor over here. And it looks like they're adjusting the gain on just the first IF stage. I've not studied the Unelco to see if they're trying to control the mixer stage as well. If you control the first IF and the mixer stage, that would be a pretty adequate automatic gain control system. Again, this schematic is representative, and it would take quite a feat of engineering to reverse the circuit using just the circuit board and coming up with your own schematic. So looking at the audio output, we come through the 5K volume pot into the audio preamp, into the driver transformer, a push-pull audio system, which is very common for this era, and the output transformer into the 8-ohm speaker. Now I suspect in the receiver that I have here that the automatic gain control capacitor is probably dried up because I'm having to put some artificial attenuation at the antenna in order to bring the signals down so that we're not driving ourselves out of the ham shack. Notice the low voltage that we're using on this receiver, only 4.5 volts. That's very clever, and that allows the receiver to use less current. Transistors really don't need much more voltage than 1, 2, or 3 volts, so why run them on 12 volts and waste the current? They already were thinking of using a lower voltage supply with larger batteries to extend the life of the receiver. And remember, with push-pull, you double your voltage swing on the output. So this is a very clever use of low voltage for the time.
Is a single conversion super heterodyne receiver. It only has one tuned circuit in front of the mixer, and that tuned circuit is controlled with this trimmer control. Since the oscillator and the mixer input are on one dual gain capacitor, that trimmer would allow you to tune in the image as well as the real signal. And we know that the IF frequency is 455 kilohertz. So let's tune in a shortwave station on the proper settings. Okay, here's some obvious ham signals on the 40 meter band. Okay, so they're in the proper band, but now let's deliberately go down. And you do it when the trimmer is in the wrong position. See how far off the trimmer is? Okay, you got to have it pretty far off to get it to tune in that image. When you're in the proper position, more towards the middle, you get better selectivity. Now, if we had a BFO, we could hear these CW signals. There it is. There's CHU. Go back down to its image. Have to tune off. There's the image. Now let's sniff the local oscillator.
Canada, 19 hours, 39 minutes.
7392. Okay, I've just picked up a random plug-in coil. This is oscillator 2, 1.4 to 3.3 megahertz. Let's take a look and see what one of these coils looks like. They just unscrew. It's threaded. Now inside we see an optimized plug-in coil. It's a scramble wound coil with Litz wire, and it's got a feedback for Armstrong oscillation. It's got a couple capacitors to get it on frequency, and they've padded it, and there's also a resistor here. Looks like that's for the tap for the oscillator. So this is a completely optimized plug-in coil. There's more going on here than just having a couple coils on a form. You can tune it, you optimize the band, and you have even some bias options here. So this is an optimized plug-in coil compared to what you're used to with just a simple wind on a coil. Also, with the core, you can control the Q, so you can get some pretty high performance in this modern plug-in coil.
I'm not going to pay that extra price when I didn't realize that I had to. And you didn't tell me, by the way, because I wasn't trained in electronics, and so it worked out quite well to be able to have access to engineers who were willing to tell me how things worked, and so on and so forth. That was a lot of fun. So back to you, Chris. AJ1G, here is K1IC.
Yeah, okay, Gary, just just stood by there in case anyone else was coming in.
Unelco uses the very popular dial string method of tuning. And a dial string, basically you have a smaller pulley that's driving a larger pulley. And it's quite excellent. There's no backlash in this arrangement. It's spring-loaded. It's quite a nice tuning dial. With a minimum of parts, they've developed a very nice receiver for the beginning shortwave listener. No, this isn't going to be as high performance as maybe even some other type of tube-type shortwave receiver. But it gets you there very quickly, and it picks up a lot of stations. It's quite impressive for the time. So is it as good as even a primitive shortwave receiver like a Star Roamer or a Space Spanner? That's hard to say. Depends on how well the beginner knows how to use and tune his receiver and how good the antenna is. But I can tell you, this gets you there very quickly. And this would have been a fabulous Christmas or birthday present in the late 60s. So I hope you've enjoyed this little video on the Unelco receiver. This really was a fun little thing. Although it didn't have very good performance on that top band, I think that this was a wonderful Christmas or birthday present for any kid of the 60s, that's for sure. And I really enjoyed mine. I went as far as to put a BFO in mine. I came up with a 1-transistor BFO, put it under the hood, and now I could pick up single sideband and code stations. Well, sort of. Not bad for left hand.